Since our initial guess of 0.5 of x2 equals to 0.5 gave us an area which is far less than the one that we want. It gave us an area of 0.283. We move on to guess another value. In this case, I chose 0.4 because 0.4 it's almost because from 0.5 to 0.6 we only have 0.1 units. Like we add 0.1 to get 0.6. So from 0.4 to 0.6 we'll have to add 0.2, which is almost double that of 0.1. So that's why I chose 0.4 as the second guess, with the aim of, if we double this, it will also double the area, which will be closer to this one, reducing the effort required to iterate. So guessing that using 0.4 as our second guess, we do the preliminary steps where we find delta x first, and we found it to be 0.67, and then we found the x naught prime up to x3 prime using this equation by just changing the I values from 0 to 3. And still here, maybe to bring your attention here, x3 we found it to be 0.601, and then we approximated it to be 0.6 because we know that it should be 0.6. So x3 prime, it represents our x3 on the graph. So after finding all the x values, we go to our graph. So on our graph, we start from the first one, x naught, which is 0.4. We just go to 0.4, draw a vertical line, go horizontal, we find our y-intercept, and then we go to x1 prime, which is 0.467. We locate 0.467 here, we go up, and then to the y-intercept we get our f of x to be 2.51, f of x1 to be 2.51. Similarly for this one, we do the same, go to the graph, we find it to be 2.8, and 0.6 is still it still gives us 3. After finding our f of x naught up until, because this is f of x naught, x1, x2, x3, we go back to this equation. Since we have x naught, x1, x2, x3, we go back to this equation here. In this case, it was x1 minus x2. Our x2, it's 0.4, since we guessed it to be 0.4. Divide by 6. We substitute these values, x1 2.8, 2 times x2, which is 2 times f of x, f of x naught is 2.28, and then we have 2 times f of x1, etc. We plug these values, and when we calculate, we find the area to be 0.53. And from here we see that 0.53, it's slightly greater than 0.51. So it means our initial guess it's off by a margin. So it means that the area is bigger. So the area that we've determined from this area, this shaded area, it's bigger. So to reduce this area, we have to move this x2 value to the right slightly. So the next guess I made was to make it 0.41. So by the next guess I made was letting x2 to be 0.41, with the aim of slightly moving this horizontal line from here to here, slightly decreasing the area to approach the true area. By following the previous steps, we find delta x first to be 0.63. use it with the second equation to find the xi values from x0 to x3. After finding these values, I went to the graph. I didn't have graph paper, so I used Excel to find the f of xy, the f of x values, and the y values. We found them to be like this using those steps, and then I plugged them here on the Simpson's rule and found it to be 0.5054 the area, which is almost close to what we needed, which was 0.512. So this is close enough. The true answer for this question was the true answer for x2 was 0.405. So if you moved on to find the to be extra accurate, you could use 0.405 and do a fourth iteration, and then you'll see that you'll get the exact value. But this is acceptable like this, and then you can say that therefore x2 is 0.41, since when you put 0.41 you do get approximately the true value, and then that will be done with the fourth step, and we'll have answered the first question. And then we can go to the last question, which is to determine the average composition. So same thing, generally you can just memorize this equation, this one here, and then you can use it to find. But I showed a bit of derivations to just show where it comes from. So this equation to find average, we find it through performing overall mass balance calculation, use overall component balance for the lead key. So from this equation, since we know V, so L1 minus L2, this is the equation given on your notes, but L1 minus L2, we know that it's equal to V, so we can just use this one. And then going here, we make Y average subject of the formula, and we end up finding Y average to be 0.885, the average vapor composition, and that will be the end of everything. But just to recap on the Simpson's rule again, since now we've done everything, we were at this point where we had Relay's equation and we didn't know x2, but we had 0.512, which we know it's the same as the area under the curve. What we did, we also let me use this one. What we did was to assume an x2 value of 0.5, meaning now if we assume to be 0.5, this equation ends up being 0.6 to 0.5 here, and then we find the area under this curve assuming that x2 is 0.5. So the first step of using the Simpson's rule, we have to start with determining the delta x, which helps us to find the spacing between the rectangles. By rectangles, I mean these things, because these blocks, and the n equals to 3. It is the number of rectangles, the n on the Simpson's rule. It gives us the number of rectangles. So delta x gives us the spacing between these rectangles, and after finding delta x, we put it on this equation. x2 is the x2 that we guessed, and the xi primes will be the x values on our graph. So this will give us the spacing between the blocks, and then this one will give us the location, the start of each rectangle. For example, the first block will be 0.4. It was for the 40%. So the first block will be 0.4. The first block will start at 0.4, as it did here. It goes up, and the second block will start at 0.467. So we have this one from 0.4 to 0.467, and we draw it like this. And then from the graph, the job of the graph is to give us the f of x values, which is just 1 over y minus x. The 1 over y minus x values, we get them from the graph by just going through each x value, and then we tabulate them here. And then after finding these values, we put them on the on the Simpson's rule equation, which is here. And that's all. Once we find the areas, if the area that we find it's less than the one that we need, it's less than 0.512, it means we move to the left. The value that we guess will be a value which is less than 0.512. And if it's greater than 0.512, the area that we determine, then we move slightly to the right to guess a new value. I hope all is clear, and try to attempt it on your own. And if you have any problems, just feel free to ask me, and I will try to explain deeper also. I'll also try to compile similar questions and send them to you guys via WhatsApp.